Well, like quite a few people on who watch this channel, I enjoy these emergency type kits, and the Midland 77-810 and the realistic TRC 1004 could be my favourites. And I needed something to do today, which was a non-customer repair and could be relatively quickly done because we have limited time on a Sunday between church services, with my main work being as a church organist. So I bought 3 of these off eBay a couple of years back, and they've been converted into some bizarre kind of walkie-talkie. Right. So what we do have is the telescopic aerial that's always missing, but no mag mount. But at least we've got the telescopic aerial that's always missing. Now I did that Maxcom 7E the other day, which is one that was kindly passed on to us by our mystery benefactor Alan. So this just reminded me of how lovely these things are. So we need to get rid of this epoxied stuff off the back, don't we? I can't really test anything until I think we've removed this back. I might have to take the front off first as well. I don't know what we're going to do. Whatever it's going to do, it's going to mar the appearance, isn't it? It's kind of ruined it. I think I paid 18 quid for the 3. So it's not like they were not the right price. Screws missing already. Now then, this will all have to be unsoldered, so I better take the knobs off. Put that to what we think to be channel 20, so at least I know roughly where it's going to go. So it's kind of converted these into some cheap type of walkie-talkie. Oh, right, so here's our next snag. Oh, no. So yeah, you've got the stud for the... Right, so unlike the Maxcom, which has the power input underneath, and the aerial socket underneath, this has the antenna jack for the telescopic provided there, then it has external aerial and external power on the top. So they've got their power, which I suppose you put a link lead between the two in the way they'd got that. That's hot glue, that might come off, but the other looks like epoxy. So, how do we take the back off? We unsolder the loading coil from the telescopic aerial socket. This is what I was on about on that Maxcom. You can't just put a BNC there because there's the loading coil. You can if you eliminate the loading coil. So hopefully this board will now come out. Oh no, they're wired. They're wired into the bottom. So I'll tell you what, just for now, we'll snip those. Ah, that's what he's done. So that is to charge. These are 500 milliamp hour, which was the maximum capacity at the time. So I've got a bit of corrosion because of the batteries. I may be able to solder in order to unsolder. So the plan is we've got to get these batteries unglued. I'll probably end up going in the organ workshop. I don't really want to make this any worse than it is. I could have used Evo stick contact adhesive. I think that's what's happened. To be honest, that's come off better than I expected. It's taken the maker's plate with it. You never know, we may be able to clean that up a little bit more later. Well, I'm not holding my breath over that. Now I want to really rescue the maker's plate without ruining it. I don't want to, I've got to be very, very careful because it's going to end up being bent. Yes, I think we'll go into the organ workshop with that and do it later. Good. Well, at least we can service the set. I'll just put some fresh solder on there while we've actually not got the board in place. There we are. I think it does look similar to the Maxcom. It's made by the same people. I've still got the... Yes, I have. Four coils, filter, that, yeah, it's exactly the same beast. There we are, good. Right, in that case then, I need my aerial adapter. Going to run over this with the fiberglass brush. I just wonder if they've used these on boats, you know. Because this method would have given him a 4 watt 40 channel walkie-talkie for less money than a normal walkie-talkie that took batteries at the time. Which way on are we? We're that way on. So all I need, he says, is a power connector. I think we are centre positive on these, but we're going to tread carefully. Now that one I was doing the other day, the Maxcom 7E, because it had come from Alan, he'd provided a connector he'd made up. So that's why I didn't have to worry about which way around it was. So I'm going to start it off at 9 volts with 100 milliamps current limiting. Yeah, that's fine. Right, we'll go to 13 point. No, it's 12 volt. 12 volt. I was going to say look on the maker's plate, but the maker's plate is still on those batteries. Well, this should be very straightforward because I only did one a few days ago, and I might even remember. So we'll start with transmit. It is presented upside down to the way Maxcom 7E is presented. So we're going to transmit. Let's put picture in picture on. These don't have high-low power. And this one's doing 1.7 watts. In fact, we'll go to the low power scale. Yeah, 1.7. Just to see if we are on channel 20. Yeah, we are. So now I'll try and find channel 40. I'm going to put the knob on because it's difficult to move it without the knob. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Should be about there. Spot on, channel 40 it is. And it's doing 1.75 watts. Let's call it 1.8. Then we'll go around to channel 1. And it's 1.7. I can't imagine these have been deliberately turned down, but who knows. So go back to what we think is channel 20. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. Probably there. Or even there. I'll not put it on frequency. I'll put it on frequency now, and then we can always adjust it in a moment. Because this test set's only been on for 10 minutes. Really wants to go on half an hour. So put it on camera 2. There we go. And what we got? Not illegally low, but it's got to the stage where it would become noticeable. Anyway, look, it's coming up fine. I like it slightly high, but not quite as high as that. Not that it matters. Go on, you swine, go down. Leave it at that. So it was 27,79074, now 27,79125, and the current on channel 20 is 609 milliamps. It would make sense to turn the power down so that it drew 609 milliamps, because with 500 milliamp hour batteries it would give you a lot more transmit capacity than if you got it drawing a full 4 watts. Right, let's go through the transmitter. So we're on our low power scale, so full scale deflection on the meter is 3 watts. That's centred. That's now centred, we're at 1.8 watts. So I've got 2.2 watt. I'm going to have to take a break and see whether it's a 12 volt radio or whether it's a 13.8 volt radio. Because this didn't come with a battery pack like the Maxcom 70, there may be some component change differences, component value differences, and this may be a 13.8 volt radio. So I'm just going to check that with the copy of the instruction book in my archives. No, well, it just says 12 volts, which isn't very helpful. It would be nice if it said a minimum and maximum. So I think we're back to, well, I'll put it on 13.8 volts. It's my own set, so if it blows up, well, that's my fault. Because it's just a little bit lower than I would expect on 12 volts. So let's see whether that's changed things. And the answer is yes, it's now 2.8 watts, which is a bit nearer what I expect. So I'll just run through this again. I've just got to watch the placements of some of these. I don't think we normally have a problem with them not doing somewhere like 4 watts, but this one's doing 3. I mean, it's not a problem, it's not faulty. So we've got 3 watts on channel 20. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. That should be about there. It is. It's 2.9 watts on channel 40. And on channel 1, just check that's channel 1. It is. It's 2.9 watts, so it's nicely centred. So no low power on these. And get back to channel 20. 1, 2, 3, 4. Yeah, that's right. And the current consumption now is 704. So we're not far off doubled the power for 5 milliamps more. Can't be bad. Deviation, we'll just check it on this one and I'll verify it with the one behind me. Wallow. It's exactly 2.5 according to this test set. So if I remember rightly, it's deviation there, and somewhere down here we've got the squelch preset. So I'm just going to pop it on the test set behind me just to check, because I say the deviation meter on this Marconi test set in front of me isn't always accurate. 9 times out of 10 it is. But it's easy enough to just verify on another test set. Voila, it's spot on. Oh, the paper's gone on the floor, but it's spot on. Right, so that concludes really the transmitter on this. So now we will go over to the receiver, so I'll set the signal generator to produce the right frequency with channel 1. So let's just go over to the frequency counter. We'll set up 2779125. There we go. So to get a reading, because we haven't got an external speaker socket, just need to pop this onto the speaker so we can read it on our cyanide meter. Just like that. So let's get a reading, and then we'll know where we are. So let's see what that reads. For 12 dB, it's 1 microvolt. Ten dB. 0.95 microvolts, and if it does 20 at any point, it does, it's 2.7. Right, so we'll see whether we can improve that at all. So I'm going to put a 100 microvolt signal on the signal generator. We'll have a look on the oscilloscope and put enough volume up to make that a meaningful trace. I think that's the detector. No, it's not. I think that's the detector. It is, and it was a bit out. Right, so we'll go to the cyanide meter and see if we can get something more out of the receiver. Got a little bit more there. No change there. And a little bit there. That's it. That's all I can do. And we've got a new figure. .9 microvolts. .85 microvolts. And 1.7 microvolts. That is where that detector was made all the difference. So that is better than spec. I think it's better than 1 microvolt for 10 dB cyanide, and it was already better than 1 microvolt, so that's alright. Not as sensitive as some sets, but within its manufacturer specification from 40 years ago. And there are some current new sets that aren't as sensitive as this. And we'll start with those 2014 Cobra 29LX EU things which look really squish but don't work very well. squelch. I like to be able to do 100 microvolts. So let's go over to the attenuator, and 30, 100, it's 300 microvolts. See where it is on the sensitive side. So we'll take the signal generator to standby, drop the squelch, set it to threshold, put the signal generator back on. It's 1 microvolt. That is okay, but I'm sure we can do better. So if we now adjust the squelch to full and adjust the preset, that's it. It's now 100 microvolts for opening at maximum. Set threshold. Now new threshold is 0.78 microvolts. So that's all fine. So, what can else? It doesn't have a meter, doesn't have an S meter, doesn't have a meter lamp. That's okay, that's okay, that's okay. It doesn't have one of those. That's okay, that's okay. Job's a good one. Now some of this power loss and sensitivity will be in the connector, but it's certainly doing, if it's doing 3 watts on this test set, well, it's doing at least 3.4 of anybody else's watts. I'm trying to put this on with the knob in place, aren't I? What a wally. So we've got a screw missing. There's a bag of Maxcom 7E parts, not case parts but electronic parts, in some of the stuff passed on to me by Alan. So you never know, there may be the missing screw. There we go. So we'll now swap the test gear, so we'll turn that off, for the aerial on the roof. Got Antron 99, as I keep saying, without the ground plane kit, mounted just above gutter level on a single story building, broadside into a roof that is an Apex concrete tiled roof. Right, let's see. One nano Roger. No Roger. No Rogers today. Right, so there's another little ready rescue. Try and clean the back of that, and we'll try and recover the maker's plate from the glue on this battery pack. We'll probably put this in a tray of solvent, like isopropyl alcohol, acetone or something and just see whether we can part those two. I don't want to start forcing it off because it's going to bend the plate. There we have it. Thanks for watching.